So, you want to become an AI engineer. You see it everywhere. This is the future. This is where the action is. But let's be honest, that title sounds intense. It sounds complicated. You're probably thinking, do I need a PhD? Do I need a supercomputer in my garage? And that's the big question we have to answer right away.
This is it, right? This is the question that stops so many people before they even start. There's this big myth out there that you need this long academic background, years of complex math, just to even get your foot in the door. Well, I'm here to tell you, that's just not the case.
Let's just get this out of the way, right here, right now. No, you do not need a PhD. What you really need is a roadmap, a practical, step-by-step plan that shows you exactly what to learn and in what order. And that's what we're going to do today. We're going to lay out that entire path for you to take you from just being curious all the way to being a job-ready AI engineer. Let's dive in.
So here's how we're going to break this down. First, we'll figure out what an AI engineer actually does. Then, we'll crack open their toolkit to see the must-have skills. After that, we'll get into the really cool stuff, the advanced techniques. Then we'll talk about taking your project from a cool idea to a real-world application. And finally, the most important part, your hands-on learning path to get started today.
Okay, so what is the big secret to being a great AI engineer? Well, it's not about memorizing a bunch of code. It's about being a problem solver. It really all boils down to asking a few critical questions, and the very first one is maybe the most important of all.
Seriously, before you write a single line of code, you have to ask yourself, is this actually solving a real problem? I mean, a cat photo generator is fun, sure, but an AI that helps a real customer track down a missing package? Now, that saves a company time and money. That creates value. So remember, don't build toys, build tools.
So, you've got an idea that has real potential. Awesome, but how do you actually know if it's any good? This is where this concept of evaluation-driven development comes in. It just means you measure your success based on real-world outcomes. Sure, you can track the nerdy metrics like factual consistency, but what really matters is, are our customers actually happier? And here's a wild trick. You can even use a super powerful AI like GPT-4 to act as a judge to grade your own AI's answers. It's like having your own automated quality control. But no matter how well you evaluate, you're going to face the biggest monster in the entire AI world, hallucinations. You know, that's when your AI just confidently makes stuff up. Taming this beast is the absolute core of what an AI engineer does. So, how do we fight it? What are our weapons? Well, that brings us to the toolkit. All right, time to open up the toolbox. These are the essential, everyday tools you'll use to build AI that people can actually trust. Think of these as your go-to weapons in the fight against unreliable AI. So what exactly is a hallucination? The best way to think about it is this. Imagine you're talking to someone who is an incredible public speaker. They sound so confident, so convincing, but they have absolutely no idea what they're talking about. That's a hallucinating AI. See, these models aren't databases of facts. They're expert word predictors. Their only goal is to predict the next most likely word. They are brilliant improvisers, not librarians. Now, your first line of defense is also the simplest. Just give better instructions. That's all prompt engineering is. You have to be incredibly specific. Don't just say, write about cars, say, act as a vintage car expert. Write a short, enthusiastic blog post for new collectors about the 1965 Ford Mustang. You give it a role, an audience, and a clear task. You can even give it a few examples of what you want. We call that few-shot prompting. It's simple, better instructions, better results. But sometimes even the best prompts in the world aren't enough. That's when you bring out the big guns, Retrieval Augmented Generation, or RAG for short. And this, my friends, is a total game changer. Here's how it works. Instead of just asking the AI to pull an answer from its own memory, you first have it look up the relevant information from a trusted source, like your company's internal wiki or recent reports. You give it the facts before you ask it to answer. Honestly, this is the best way to think about RAG. It turns every single question into an open book exam for the AI. It doesn't have to stress about remembering something it learned a year ago. Instead, it gets to look at the textbook, your data, find the answer on the page, and then use it. This is, hands down, the single most powerful way to fight hallucinations. Okay, so you've mastered prompting. You know how to use RAG. You can now build an AI that's reliable and trustworthy. But now let's make it powerful. Let's look at the advanced stuff that gives your AI some real superpowers. So what in the world is an AI agent? Well, it's an AI that doesn't just talk, it acts. You give it a mission and you give it a set of tools.
So the mission might be, book me a table for 2 at a good sushi restaurant tonight. And its toolbox could have a web search to find restaurants, a review reader to check ratings, and an API to actually make the reservation. It goes out and accomplishes a goal for you.
Now, this is a super important distinction that confuses a lot of people, so let's make it really simple. When do you use RAG, and when do you use this other thing called fine-tuning? The rule of thumb is right here. RAG is for knowledge, and fine-tuning is for behavior. If you need to teach your AI new facts, like what's in your latest company reports, you use RAG. But if you want to teach it a new style, like how to write with your company's unique, quirky brand voice, that's when you use fine-tuning. Knowledge versus behavior. It's that simple.
So you've built this amazing AI. It's smart, it's reliable, it works great on your laptop. But now it's time to release it into the wild. And let me tell you, a cool demo is one thing. A real, robust product that thousands of people can rely on every day, that's a whole different ballgame. Let's talk about getting it production ready. Okay, when you go live, 3 things become absolutely critical. First, you gotta make it faster and cheaper. That means using smaller, more efficient models, and using tricks like quantization, which is basically like compressing the AI's brain so it runs quicker. Second, it has to be secure. You need to build guardrails to stop people from trying to misuse it, and to stop the AI itself from saying something inappropriate. And third, your AI has to get smarter over time. You need to build in simple feedback loops, like a thumbs up, thumbs down button, so you can collect data on what works and what doesn't, and use that to constantly improve.
We have covered a ton of ground. But look, theory is one thing, actually rolling up your sleeves and building this stuff is another. So the big question is, how do you actually get started? How do you put all this into practice? You need a clear path.
And here it is, your 3-step plan. Step 1, get the theory down. Start with a solid resource like the AI engineering book to build that foundation. Step 2, practice. This is crucial. Get your hands dirty on a platform like DataCamp, where you can build real projects, build a RAG system, use frameworks like LangChain to connect all the pieces. And finally, step 3, get the proof. Go out and get a practical certification that proves to employers you don't just know the buzzwords, you can actually build real working applications.
And that's it. That's the roadmap. We just went from, do I need a PhD, to a concrete plan to become a certified AI engineer. As you can see, it's not about some impossible academic hurdle. It's about having a process, knowing the right tools, and getting hands-on. So now you have the plan. The only real question left is, what problem are you going to solve first?